What if you drilled a hole through the earth and jumped in? Let's say, for the sake of curiosity and a very questionable sense of adventure, you decide to dig a hole straight through the center of the earth, from one side all the way to the other. No curves, no tunnels turning off into mining shafts, just a perfectly straight vertical tube going right through the earth's core. First, congratulations. You've just invented a drill that can go through 12,742 kilometers of rock, molten metal, and pressure that would turn a battleship into a pancake. But let's assume, somehow, that the hole exists. It's lined with heat-proof, pressure-resistant, frictionless material. There's no air resistance, no molten rock pouring in, and nobody yelling at you about how this would cost more than the GDP of the planet. It's just you, and a big hole. You step up to the edge, you look down, you take a deep breath, and then you jump. At first, it feels a lot like skydiving. You accelerate quickly, thanks to gravity pulling you toward the center of the earth. In fact, you accelerate at 9.8 meters per second squared, just like anything else dropped near Earth's surface. But this isn't just a skydive. There's no parachute, no plane above you, and the fall doesn't stop at a few thousand meters. As you descend, gravity starts to change. See, gravity pulls you toward the center of mass. At the surface, that's straight down. But as you go deeper, more and more of Earth's mass is now above you. The stuff that used to pull you down is now behind you, trying to pull you back up. The net gravity decreases the deeper you go. At the halfway point, the very center of the Earth, gravity is zero. Every atom around you is pulling in every direction equally. You float for the briefest moment, but you're not stopping, because you're still moving fast. In fact, you've been falling for about 21 minutes now, and you've reached an insane velocity, around 28,000 kilometers per hour. That's faster than most spacecraft in low Earth orbit. But just like a roller coaster going up the other side of a hill, you start to slow down. Now, gravity is working against you. It's pulling you back toward the center, trying to undo everything you just did. You're basically moving through Earth's gravity like a pendulum. Momentum carries you up toward the surface on the opposite side, slowing down as you go, until, if nothing interferes, you reach the exact same height from which you jumped. In theory, you'd pop out the other side of the Earth, maybe somewhere in the Indian Ocean, if you started in Kansas. You'd pause in mid-air for a fraction of a second, and then begin falling all over again, back down through the planet. This is what physicists call simple harmonic motion. Like a child on a swing, you'd go back and forth forever, unless friction got in the way, which in the real world, it absolutely would. Even if you had air in the tunnel, air resistance would slow you down fast. You'd reach something called terminal velocity, about 200 kilometers, and the air pressure near the Earth's center would be so intense you'd be crushed before you got there. It would be like diving into a wall of atmosphere thicker than the inside of a gas giant. And even if the tunnel were magically evacuated, no air at all, there's still mechanical friction. Tiny imperfections in your tunnel walls, gravitational anomalies, heat, or just your body slightly brushing against the side would slowly rob your energy. Each swing would be slightly shorter, slightly weaker, until eventually you'd settle at the center of the Earth. Forever. Suspended. Weightless. Trapped in total darkness, with the core of the Earth glowing somewhere just meters away, but unreachable, surrounded by more rock than exists in every mountain range on Earth combined. A poetic way to die, maybe, but definitely not recommended. But let's rewind. What if we could use this concept instead of dying from it? Physicists have long theorized about using Earth's gravity to create an ultra-fast transportation system. Gravity trains. Imagine stepping into a capsule And instead of being blasted forward with rocket fuel, you're just dropped into a vacuum tunnel that curves through the Earth. No engines, no emissions. Gravity pulls you down, then slows you down as you rise. The whole trip, say from New York to Sydney, could take just 42 minutes. It's wildly impractical. The cost, the engineering, and, let's be honest, the fact that you'd need to drill through countries, oceans, and the literal mantle make it a fantasy. But on paper, it's beautiful. So, could you drill a hole through the Earth and jump in? Technically, no. Not without breaking every law of geology, physics, engineering, and common sense. But in a frictionless vacuum tunnel with magical heat shields and no air. Yes, and if you did, you'd fall, rise, like a pendulum inside a planet-sized grandfather clock. Until eventually, you stop. Still, in the heart of the Earth. Forever. Unless someone invents a ladder long enough to pull you out.